So let's talk about some properties of the dot product that will be useful in our computations. So first we have that A dot B is going to be 0 if A is perpendicular to B. So if we recall a sort of orthogonal basis like ijk, where the angle between each of the unit vectors is 90 degrees, then from the definition, where we have cosine theta, we know that we're going to end up with 0 because cosine of 90 is 0. Similarly, we have A dot B is going to be plus or minus the product of the magnitudes of A and B, and that's if A is parallel to B. So we could have, for example, A and B parallel like this, or A and B could be anti-parallel like this. Of course, it follows, but it's useful to write down. A dot B is going to be plus or minus 1 if A is parallel to B and both of the vectors are unit vectors. And we denote that by the little hat symbol over A and B. Next, we have the commutative law of dot product, which means that we can reorder the vectors as we please. So A dot B is equal to B dot A. And if we look at the definition, it makes sense because we know that multiplication is commutative. And from this, we can also say if we have constant multipliers on our vectors, like C1A dot C2B, we can pull the constants out in front, because again, the multiplication and the dot product are both commutative. Next, we have the distributive law. This is very similar to multiplication in that we distribute the dot product across a sum. So in this case, A dot B plus C will simply become A dot B plus A dot C. And similarly, if we have a larger vector expression, like A plus B dot C plus D, then we'll dot A with both C and D, and then we'll dot B with both C and D, and add all the results together. So there we have some properties of the dot product that are useful to remember when doing computations.